Good morning. Welcome back to Chapter 22 Notes. I know yesterday was kind of overwhelming, or Friday, since we had about 49 minutes worth of notes. It was the biggest day that's left. It's just one of those that's kind of a killer day. The good news is it's on video, so you can start, stop, pause, take a nap halfway between if you have to. So not as bad as being trapped in a room with me, I don't think. With 49 minutes of lesson all in one fell swoop. The good news is today's is 2 slides long, so much shorter and a lot less overwhelming. So not a lot of new stuff. Really, we're going to do another confidence interval, but in this case, instead of getting summary statistics to work with, we're going to get the raw data. We actually have the observations. So we've got to learn how to deal with that differently than we did the raw data. Couple extra little things we have to do here, but still in the big scheme of things, it's not a lot more work than what we did with proportions. So let's just jump right to it. So the Consumer Reports Organization tested 14 brands of vanilla yogurt, found the following numbers of calories per serving. So we have observations. This brand of yogurt had 160, this brand of yogurt had 200. We don't get this kind of information in proportion world because in proportion world, observations are just yeses and nos, successes and failures. This is pretty boring. So we have more interesting things to work with in quantitative world. We're going to create a 95% confidence interval for the average calorie content of vanilla yogurt. So there's 2 things in this problem that clue me into the fact that I'm in quantitative world. One is the fact that I have units. That never happens in proportions. The second is that I actually have numerical values. That never happens in proportions. In proportions, all you do is get a fraction or a percentage of successes. And the third one is this word average. So you've got all kinds of clues here that you have quantitative data. And any time you work with quantitative data, you have to work in T world. And if you have categorical data, you have to work in Z world. So it's a really clearly defined 2 different groups of inference procedures. All right, let's check our conditions. Nowhere in here did it say this was a random sample, so I'm not going to say it was a random sample. I'm not even sure that I can assume they took a random sample. What I can hope for is that these 14 brands are representative of all brands. So let's argue that one. Assume these 14 brands are representative of all brands of yogurt. Okay, the 10% condition or independence. Now the 10%, I'm a little bit, I find that one a little bit uncomfortable here because I'm not sure if there's 140 brands of vanilla yogurt. There may be, and Consumer Reports is an American magazine, or it's an American organization. So even in the United States, do we have 140 brands of vanilla yogurt? Maybe, I don't know. But I'd rather argue that each of these brands has an independent amount of calories. That's maybe a little safer here. So I'm going to assume the calorie count, or the calorie counts of each brand are independent. Okay, and I said assume, which means I don't know. The good thing on the AP exam, and we'll start looking at sample questions from AP exam as soon as we finish these last 3 chapters, and that's all we're going to do for the rest of the year. You'll notice in those that it'll usually say in independent random samples that those words will be in the problem stem most of the time. An independent random sample was taken, they'll throw in a couple magic words there so that you don't have to assume, you can just know. So we like that. Okay, so the third one is the sample size condition. So we've got two things we could go with here. If our sample size is 30 or bigger, the central limit theorem will back up a nearly normal distribution. 14 is definitely not 30 or more. So we have too small a sample size. If we knew that all vanilla yogurts made a normal model, then we could go with a smaller sample size and 14 would be big enough. We don't know the shape of the picture of all vanilla yogurt brands' calorie counts. We just don't know it. So now what do? Well, if we go back and look at yesterday's notes, if n is less than 30, then if we have the data, we can look at a picture of the observations that we do have. So we can take a look at this sample, and if this sample is reasonably unimodal symmetric, if it's not terribly skewed, if it's not weird shaped, then chances are all of the possible yogurt brands are going to make a similar picture, because typically you get even prettier unimodal symmetric graphs with bigger samples if you get a unimodal symmetric graph with a smaller sample. So if this sample has a pretty picture, then I'm going to argue that the entire population probably is not terribly skewed and we can get by with a smaller sample size. So let's look at a picture. We could do a dot plot, we could do a box plot, we could do a histogram, lots of different options. What you don't want to do is put it in the calculator and copy it down. Like, put your data in and copy a graph from the calculator. The graphs on the calculator are not good for copying on paper. They never will be. Don't go there. So let's make our own graph. So we have a lowest number of calories of 80 and the biggest is 230. So from 80 to let's say 80 to 240, that's a span of 660. Maybe if I count by 40s, I would get a pretty decent graph. Okay, let's try that. So try to pick a scale that'll work. So this is my calories, and I'm going to put my lower bound at 80. 120 is 40 bigger than 80, then 160, then 200, then 240. Pretend those are evenly spaced and beautiful. Maybe it should be like there. Okay, so I'm going to squeeze a histogram in here. And let's see, from 80 to 120, not including 120, how many do I have? 1, 2. The 80 and the 100. Okay, so I'm going to make this 2 units tall, and because I don't want to make an axis, I'm going to just pile up a couple blocks there. And then from 120 to 160, not including 160, we have 1, 2, 3, 4 observations. So 1, 2, 3, 4. So about to there. From 160 to 200, not including 200, we have 1, 2, 3, 4, 5. So 1 block higher than the last one. And then 200 to 240, we have 1, 2, 3 of those. So 1, 2, 3 is about here. Okay, there's my histogram. So I crunched that out pretty quickly. And that's going to be faster than trying to use data in the calculator to build a histogram to copy on paper. It's a lot of work to get a histogram with a good bin size. Best case scenario is a bin size of 5 to 8, or a bin number of bins from 5 to 8. But this is a fairly small set. With only 14 brands, you don't want to go too small on your scale because it's going to chop it up so much that you're really not going to see a clear shape. Okay, this is definitely unimodal. It is maybe a little bit skewed to the left, but not terribly so. So it's not severely skewed. So I'm going to argue that this is reasonably unimodal symmetric. Pretty nice, actually, for such a small sample size. All right, so condition number 3, I'm going to say the histogram is unimodal and reasonably symmetric. So the sampling model, that graph we're going to draw to use in the mechanics, or actually we're not going to draw it here, the one that we're going to have lurking in the background. The sampling model should be nearly normal. Now, this is more work than what we're accustomed to having to do on that third check, but you only have to do this if you have a small sample size and you know your data. Sometimes they don't give you the data and they will tell you that the graph is not skewed. And if they tell you the graph is not skewed, then you can assume that this has already been looked at, and you can just say the graph is not skewed, so nearly normal. You only have to draw the picture if you don't already know what the picture looks like. You typically, if you get data, don't know what the picture looks like, so you'll need to draw a sketch. Okay, so we're going to say those three check reasonably well. So we will do, we'll say a T model can be used. Create a one sample T interval. Alright, the worst is over by far. The worst is always just checking conditions, especially that third one. So the confidence interval itself goes really, really quickly. Okay, so we have a blank space on the next slide to do the mechanics and write a conclusion, and that's all the space we're going to need. So I'm going to just, as a reminder, put at the top what our formula looks like. So our point estimator is our mean of the y's. We don't know the mean yet. We have the raw data. They didn't tell us the mean. We actually need to compute that. Plus or minus a T star with 13 degrees of freedom times S over square root of n. Alright, so that's our formula. Let's start substituting some numbers in, except I don't know those numbers. I don't know any of those numbers except sample size and degrees of freedom. So that's where I pull out the calculator and let the calculator do the hard part. So I need the calculator to give me mean and standard deviation. Okay, so let's get a spreadsheet. Control, add page, and add a list and spreadsheet. Let's call the first column, well, we just have one column, so let's call it CALS for calories, or you just leave it A. You could call it A and keep your life simple, and then skip that formula line, and let's just key in our data. So 160, 200. If I get ahead of you, feel free to pause me. And it's always a good idea to double check, because your reader's never actually going to get to see what you typed in the calculator. If you have one typo, it's going to throw all of your numbers off, and you really have no way for them to figure out what went wrong other than to assume that you had a typo. So don't have a typo. If they give you a problem with data on AP exam day, it's going to be a shorter list of data because they know you don't have time to work with a really long list. So they're just not going to ask you to do a long list. So do take the time to double check. Now, we have a long way and a short way to do this. The long way is to run the one variable statistics to get the mean and standard deviation and plug it in. The short way is just to go ahead and run the test. And you can run the test in this screen, or you can run the test on the calculator screen, which I think it's a little easier to look at there. So I'm going to control left to go back to a calculator page, or you can add a new calculator page if you need one. And I'm going to run the actual confidence interval here. I think I said test. I should have said confidence interval. So menu, statistics, number 6, confidence intervals, number 6. And we're going to run that T interval. It's the same command we used yesterday. The difference today is we don't have summary statistics, we have data. So I'm going to make the data input method the data itself. So just click on OK. And it's going to ask you, what list is your data in? Oh, okay, so I'm going to drop down the list calories or type in cals. Another thing you can do here is you can type in the list manually here and skip the step of putting it in the spreadsheet. But you have to remember to put it in braces, which would use this key. You can't see it right now. Down here beside the 0, the second function for the close parentheses is braces. You have to include that list of numbers in braces separated by commas and make it look like set notation. Otherwise, it won't understand what you're doing. So I think the spreadsheet's kind of the natural place for us to put things in, and it's a little easier to key in that way. The frequency list is how often you count each number, and we want that to stay 1. 95% confidence is what we're looking for here, so click on OK. And the good thing about this tool is it gives you everything that you need. You know your mean, you know your margin of error, which you don't have to calculate separately. S of x is the standard deviation, degrees of freedom, and everything is here except for the t-star. That's the only thing you're going to have to compute separately. So let me just start writing down some things. So y bar, x bar are the same thing. That's 157.86-ish. And plus or minus, I'm going to leave a space for t-star until I find it, times s, which is 44.75, over square root of n is 14. And I'm going to go ahead and write down my interval while I'm on this screen. So the lower bound is 132.02 calories, and the upper bound is 183.70 calories if we round up. So all of the number crunching gets done in one fell swoop other than the t-star. Now t-star we have to sort of do on the side. So I'm going to go over here and get my thinking space. I need 95% confidence, which means I need the 2.5% in this lower tail. T-star is this upper boundary. The area below T-star is 0.975. So I need to use my inverse T command to find that T-star. Alright, menu, probability or statistics, distributions, inverse T is number 6. The area is 0.975. Degrees of freedom is 13. The t-star that I need is 2.16. Okay, so I plug that in. All the calculations are now finished. So the mechanics themselves are super easy if you just run the confidence interval tool on the calculator. Everything is there in one piece other than t-star. We're ready to summarize. So we are 95% confident that the average calorie count per serving for all brands of vanilla yogurt is between 132.02 calories and 183.70 calories. Alright, so kept that one under 20 minutes today. Not too bad. Now practice, because practice makes perfect, or at least better. Alright, your day 2 homework is in your PowerPoint. Have a good one.